Welcome. In the first module, I am going to explain about the working of issues and pull requests in GitHub. I am using the WD401 repo for this demonstration. As we can see, there is a single branch. Initially, we are creating an issue which we can later merge with our pull request. I am creating a sample title and description. It should be detailed in real case. So a new issue has been created. Our issue number is 4. Currently, we are working on our main branch. In order to create a pull request, initially I am creating a new branch. Which is achieved with command git checkout -b and branch name. In our case, it is a develop. So we have successfully created a new branch named develop. I am making a change in our code base. I am committing with these changes to the branch. So after the test, our commits have been successfully created. Now we can push our new branch to the remote repository. Now a new branch with the changes have been created in our remote repository. As we can see, this develop branch is one commit ahead of our base branch, that is main. Now we can create a pull request to merge this development branch with our base branch, that is main. We are creating a pull request with the command ghpr create. We can give the assignee, that is myself, and the title. Adding the body of the pull request. We can link our pull request with the issue by adding some keywords like clauses with the issue number, that is 4 in our case. We have to define the base, that is main, and head, that is develop in our case. So a pull request has been successfully created. As we can see, a new future pull request has been created, which also triggers our CI/CD pipeline. Now We are going to merge this pull request with our main branch, which can be achieved with command ghpr merge and our branch name, that is develop. We are creating a merge commit and also deleting the local branch. Now we can see a new commit has been created, which merges our pull request to the base branch, and the issues are also automatically closed. That's it for this module. In the module 2, I am going to demonstrate how I have implemented JS bundling in my project. Initially, we need to install the dependencies. We are using Webpack for JS bundling. We have to install all the dependencies for Webpack and loaders. The loaders are used for CSS and images. Once we have installed all the dependencies, we need to create a configuration file, that is webpack.config.js. In our configuration file, we are defining the mode, which is the environment. In our case, that is development. The entry defines the entry point of our application, that is index.js. The output is the file which will be generated by bundling our code. We have rules for bundling our CSS and images, which are using loaders. We have plugins to create the HTML files. We have also implemented optimization techniques for splitting our code into multiple chunks. I am running the Webpack in development environment. The bundling has successfully created. We can see a dist folder has been created with the bundling code. We can check the running of our application. So our application is successfully running on local port. We can also check the bundling technique in production environment. We have created a script for that. While running a npm run build, we are running Webpack in production mode. Let's check that. Therefore, the JS bundling is successful in the production mode also. This is how we can bundle our code into multiple chunks. In the module 3, I am going to demonstrate compile to JS in our application. In order to implement compile to JS, I am using TypeScript in my application. Initially, we need to install TypeScript, which can be achieved with npm install TypeScript. Once we have installed TypeScript in our application, we can initialize TypeScript, which can be achieved with the command npx tsc-init. This command will create a configuration file in our application. A configuration file has been successfully created. We can edit this file according to our need. I have a sample JS file. I'm going to convert this JavaScript file into a TypeScript file. which can be achieved just by changing the extension. I'm changing the function in TypeScript. TypeScript is a strongly typed language which will reduce errors causing by type errors. We have created a sample TS file which can be compiled to JS. To compile this file to JS, I am using the command npx tsc and file directory. This command will compile my TypeScript file into a JavaScript file. So this is how we can compile a language to JS. The best option is TypeScript. The other option is Babel. In the module 4, I am going to demonstrate how we can add unit test and integration test to our project. I am using the to-do application which we have created in WD201. To run the unit test, we need to install Jest, which can be achieved with the command npm install Jest. Once we have installed Jest, we can write some unit test in a separate folder for unit test. Here I have added several unit tests for our application to check all the functionalities. I have also adjusted the script to run the unit test. The script will also create a coverage report. To run the unit test, we are using the command npm test. So all the migrations are running in the testing environment and our unit tests have been passed. A coverage report has also been generated. Similarly, to set up the integration test, we need to install Cypress. Once the Cypress is installed, we need to run the command npx cypress open. This will create a configuration file in our application. Now we can add our integration test in the separate folder. We had added several integration tests for our application. To run these tests, we need to start our application. I am using a clean start. In the testing environment, our application is live on port 3000. Now we can check our integration test with the command npx cypress run. Our integration test has been started. As we can see, all our integration tests have been passed. So this is how we can implement unit test and integration test in our application. In the module 5, I am going to explain how I have implemented CI/CD pipeline into my application. To create a pipeline, we will create a YML file in the directory .github workflows. This pipeline gets triggered on push or pull request to the main branch. It runs the Ubuntu latest. It uses Postgres for database Initially, we are checking out our code and setting up Node.js. We are installing all the dependencies and running unit tests and integration tests as well. Once our tests are complete, we are setting up Docker. We are creating a Docker image and pushing to Docker Hub. We are also creating an image for Postgres. We are setting up Azure credentials, and with the generated images, we are deploying it to AKS. So this pipeline will automatically deploy our application to Kubernetes. We will also receive a notification on Discord on success or failure of this pipeline. Let's see how this works. We have untracked change. I'm committing the change, which will trigger the unit tests. Our changes are successfully committed. Let me push these changes to remote repository. A new commit has been made. It will trigger our GitHub actions. The containers are initializing. We are pre-setting up our Azure credentials and checking out our code. Our Node.js is ready and we are installing the dependencies. We are running the unit test for our application. The unit test runs successfully. We are also running the integration test. So the integration test is also successful. We are setting up Docker to build images. Our images are being built and pushed to Docker image. Our images are being pushed to the Docker Hub. Once our images are ready, we are deploying it to AKS. As we can see, our CI/CD pipeline is successful. We have also received a Discord notification. That's it for this module. In the module 6, I am going to demonstrate about the environments available in our application. An environment is a digital space for development, testing and production. In our application, we have three environments. The environments are development, testing and production. We have all the configurations in the env file for these three environments separately. Use these configurations to access our database in three different configurations. Development is a space where we develop a feature locally. Testing is a space which simulates production but run our application locally. But production environments runs our application in remote. It is where we finally launch our application. Working on different environment allow us to develop feature without errors. That's it for this module. In the module 7, I am going to demonstrate how we can containerize our application. Initially, we need to install Docker in our application. Then, we need to create a Docker file. In this Docker file, I have implemented a base image. I have defined the working directory. I have copied package.json and package.log.json files. Then I am installing all the dependencies. The copy command will copy all our files to the Docker image. We are exposing the port 3000 and we are running the command npm start, which will start our application. I have also written a Docker compose file. This compose file consists of two services. One is for database and other is for our application. Our application depends on this database. To Dockerize this application, we need to run the command docker compose up -- build. This will build our application and create a Docker image. As we can see, a Docker image have been successfully created for our application. Our application is ready on port 3000. So this is how we can containerize our application. That's it for this module. In the module 8, I am going to demonstrate how we can implement internationalization and localization in our application. Initially, we need to install all the dependencies, that is i18 next, React i18 next, i18 next browser language detector. I have already installed all these dependencies. Once we have installed all the dependencies, we need to pick the key terms which we are going to translate. For translation purpose, we can use Tradura. Then we can export the translated JSON files. We have translation for several languages like German, English, French, Hindi, Portuguese and Tamil also. So these are our key terms which are translated to different languages. Once our JSON files are ready, we can import this via a configuration file called i18n.ts. We are using the translated resources. Once this setup is ready, we can use these keywords in any of our components by using a hook. For example, in our sign-in page, we are using the sign-in word with the T hook. We are using the use translation hook to get the keyword with different languages. We have also used several functions to detect the time and date format of the locale. So this is the working model of our application. As we can see, our application gets translated by the language we select. Not only the language, but the time and date format is also adjusted according to the locale. This is how we can implement internationalization and localization in our project. In our ninth module, I am going to explain how I have configured Sentry for error tracking in my application. Initially, we are creating a Sentry account and a project called WD301. Currently, there are no issues in my project, which means there are no errors recorded by Sentry. To install Sentry in our application, we are using the command npm install at sentry/react. It will install Sentry in our application. Once we have installed Sentry, we need to configure it. For that, we are using the command npx at sentry/wizard at latest -i source maps. It will create a white plugin in our application. It will also create a Sentry API endpoint in our environment file. As we can see, an authentication token has been created by Sentry. Then we run our build, which will create a source map and upload to Sentry. Our build is successful. The source maps have been successfully uploaded to Sentry. In our application, I have created an intentional bug. I have changed the index value so that it will cause an error. I have also added the debugger statement which will pass our compiler during the execution. I'm running the build. When we run our preview, the dragging of task will cause an error. The debugger statement has passed as it is causing an error. We can check the error in the console. We can also inspect this using React Developer Tools. When we continue our execution, it will cause an error to our application. This error will be sent to Sentry. As we can see, a new issue have been created in Sentry. The Sentry has identified the error. It will also send a notification to Slack. So this is how I have configured Sentry for error tracking and debugging in my application. In the 10th module, I am going to explain how I have included generative AI in my application. I have used Google Gemini. I have added a feature to add a to-do with natural language. To implement this, I have created an additional form in our application. As we can see, there is a form to add a to-do with natural language. To implement this feature, we are getting an API from Google Gemini. Once our API is ready, I am creating a function. Our function creates a function call which will return an object with two properties, text and duet of type strings. We are also passing a system prompt with additional information to get an customized output. This will create a output of type JSON. We will use this JSON to add a to-do in our application. Let's see how it works. I am adding a to-do with natural language. For example, lunch today. Yes, our today is successfully added. Let's try another example. Go to gym tomorrow. It is working fine. When our information is insufficient, it will give an error message like remind me with no subject and date. It will give an error message. So this is how we can implement generative AI in our application. We can also use OpenAI for this purpose. Thank you.